So, what does it really mean to be intellectually strong? Is it about being the loudest person in the room or winning every single debate? Or is it something deeper, something more powerful? Let's dive in and find out. It all starts with this idea, or at least the first half of it. A brain is too precious to waste. Okay, but waste on what exactly? How you answer that question gets to the very heart of what intellectual strength is all about. And here's the rest. The best way to honor that precious brain is by calmly presenting converging evidence and inviting verification. See, this is the core of it. True intellectual strength isn't about being right or winning an argument. It's about finding the truth and inviting other people to see it for themselves. All right, so for this first part, we're going to dig right into that idea. We're talking about moving past just, arguing back and forth. It turns out there's a much more powerful way to understand things. And that brings us to a really crucial point. Here's the deal. Not all ideas are created equal. You have to be able to draw a line in the sand between what someone just believes, their opinion, and what's actually real. The stuff that's backed up by solid evidence. I love this quote. It just nails it. Reality does not bend to opinion. I mean, you can argue with gravity all day long, but if you step off a roof, you're going down. The evidence doesn't need our permission to be true. It just is. Okay, this slide breaks it down so perfectly. On one hand, you've got dogma, right? It's rigid, it's based on belief, and it never, ever changes. But then you have science, which is the total opposite. It's conditional, it's based on evidence, and the best part, it's revisable. It's the difference between trying to force your ideas onto the world versus actually taking the time to listen to what the world is telling you. So what does it actually mean for science to listen? Well, it's not about memorizing a bunch of facts from a textbook. It's a method. It's a really powerful process for figuring out how the world actually works. And if you boil it all down, this is what you get. Science is a super disciplined way of listening to nature instead of just shouting our own ideas at it. It's about having the humility to put our own assumptions on the shelf for a minute and just see what the evidence has to say. And yeah, there are rules to this game. Science isn't about feelings. It demands proof. First up, measurement. You have to be able to measure it, put a number on it. Second, replication. Can other people working totally independently get the same results you did? Super important. Third, peer review. You have to let other experts in the field kick the tires on your work. And finally, number 4, falsifiability. This one's a biggie. Is there a test that could actually prove your idea is wrong? If not, it's not really science. All of these steps are what give a scientific conclusion its serious weight. And this right here, this might be the most important part of the whole process. If brand new evidence comes along that contradicts what we thought we knew, science doesn't dig in its heels. It updates. It actually changes its mind. And that self-correction, that willingness to be proven wrong, that's not a weakness. That is its single greatest strength, hands down. So, this amazing self-correcting machine leads us to probably the most powerful concept in this whole explainer. It's called the power of convergence. This is what happens when you have a whole bunch of different, totally independent pieces of evidence, and they all just happen to point to the very same conclusion. It's like multiple witnesses all telling the exact same story. Okay, let's look at some real-world examples. We'll start with a classic one. We've actually known the Earth is round for thousands of years, since the ancient Greeks. But how are we so rock-solid certain about it today? Well, check out this convergence of evidence. You've got the simple geometry the ancient Greeks used with shadows. Then you have, actual pictures from space, from satellites. The complex math of orbital mechanics that makes our GPS work. The very flight paths that airlines use to save fuel. And even super precise measurements of gravity all over the planet. These are all completely different ways of looking at the problem, yet every single one of them leads to the same answer. Our planet is a sphere. All right, next case study, evolution. Now this one can get confusing for people, but it's really two things. It's a fact that life on Earth changes over generations, and it's a theory that explains the mechanics of how that change happens. And once again, it is all about that convergence. We've got the fossil record showing these incredible transitions over millions of years. We can compare the anatomy, the bone structures of different animals. We can look at how different creatures develop as embryos. We can map out where species live, that's biogeography. And maybe the most powerful evidence of all? We can literally compare the DNA sequences between species. We're talking about 5 completely different fields of science, all pointing to one undeniable conclusion: a shared ancestry. Okay, case study number 3, modern climate change. And look, this isn't about politics or opinions. This is about physics. It's about atmospheric chemistry and the planet's energy budget. And the key thing is, we can measure it. And guess what? The evidence converges here too. We have temperature readings from satellites orbiting the Earth and from thermometers on the ground. We can physically measure the massive amount of heat being absorbed by the oceans. We can drill deep into ancient ice sheets and analyze the air bubbles trapped inside to see what CO2 levels were like hundreds of thousands of years ago. We can even use a technique called spectroscopy to see exactly how CO2 in the atmosphere traps heat. All these different data sets, all telling the same story of a warming planet.
All right, for our last case study, let's talk about the moon landings. So how can we be so confident they really happened? Easy. We don't have to take any single person's word for it.
First of all, there is literally stuff the astronauts left on the moon. These things called retroreflectors. And observatories all over the world, totally separate from NASA, can shoot lasers at them and get a signal back. They're still doing it today. And think about it, during the missions, rival countries, like the Soviet Union, were tracking them in real time. They would have loved nothing more than to expose it as a fake. But they couldn't. Why? Because it was real. Okay, so here's the big takeaway from all these examples. The roundness of the Earth, evolution, modern warming, the moon landings, these are not just opinions up for debate. They are rock-solid conclusions. And what makes them so solid is that they're each supported by a whole fleet of independent lines of evidence that all point in the exact same direction. That's the difference between a strong conclusion and a simple opinion. And that brings us full circle, right back to where we started. How can we truly honor our own minds? By learning to think this way. By grounding our understanding of the world in evidence that we can actually check for ourselves. And I want to leave you with one last really powerful thought. Evidence is indifferent to acceptance. Reality doesn't care whether we agree with it or not. It's just going to keep being reality. Real intellectual strength isn't about bending reality to fit our beliefs. It's about bending our beliefs to fit reality. So I'll leave you with this question. We live in a world that is just flooded with noise, opinions, and constant disagreement. So the question is, how are you going to use your intellectual strength? Are you going to be the person who calmly presents converging evidence, or the person who just projects their beliefs onto the world? Ultimately, that choice is yours.